I'm really happy to be here today to tell you a little bit about the work that we've been doing with the Athabasca Watershed Council for a little over a year now. And this project is one of several riparian assessments that we've undertaken in the last 5 years. And Mary Ellen will be here later this morning to discuss this larger sort of provincial initiative. But today I want to tell you, sort of give you a high-level overview of the methods that we use to assess the riparian areas, and then specifically talk about the results from the work that we've done in the Pembina River Watershed. So before I dive into the overview of the methods, I just want to quickly define what we mean when we say riparian habitat. Riparian habitats are found along the shorelines of all aquatic features. So this includes lakes, it includes streams, rivers, creeks, wetlands. And riparian habitats are special and important because they're transitional areas between purely aquatic ecosystems and terrestrial upland systems. And so these areas have characteristics of both terrestrial and aquatic ecosystems, but hydrology is the sort of primary major driver of a lot of the ecological processes that we find within riparian areas. And you might be wondering why we're interested in assessing and managing riparian habitats, and the short answer is that they provide a really important and wide range of really critical ecosystem services that humans and human communities benefit from. And some of these include things like mitigating flood risk and improving water quality. But from a biodiversity perspective, if you're interested in managing wildlife and vegetation communities, they're also really incredibly important. They provide habitat for a large number of species, including many of our threatened or endangered species here in Canada. And they also provide really important corridors for the movement of wildlife and genetic material across fragmented landscapes. And so they're really important from the perspective of maintaining wildlife populations. So I would argue that it's pretty easy for us to make a case that riparian habitats are really important, but as with many important habitats and ecosystems, riparian habitats often suffer from what I call the measurement problem. And you've probably heard the saying, it's hard to manage what you don't measure. And in my opinion, riparian habitats are one of the poster childs of this particular problem. So if you're interested in managing riparian areas or any natural habitat for that matter, one of the first questions you need to answer is how much do we have? And this probably on the face of it seems like a really straightforward question, but actually getting the answer to this question is not straightforward at all. And it's because while we know that all aquatic habitats have riparian areas associated with them, we also know that the width of riparian areas varies considerably. And it varies from location to location based on topography, based on soils and other local conditions. And so it's actually really difficult for us to precisely measure and answer the question, how much riparian habitat do we have in Alberta? But we can pretty easily estimate the length of the shoreline that we have in Alberta. And because we know riparian habitats are associated with all shorelines, estimating the length of shoreline is actually a pretty good starting point for our purposes. And so if we want to ask and answer the question, how much shoreline do we have? That's something that we can actually put some numbers around. So if we use the provincial government hydrography data, we estimate that there's about 237,000 kilometers of lake shoreline and about 1.2 million kilometers of rivers and creeks and stream shoreline when we consider both the left and the right bank of watercourses. And so together, we estimate that there's about 1.5 million kilometers of shoreline, which seems like an awful lot, but I think it's also a bit of an underestimate because we know that this provincial data doesn't include all of the aquatic features that we might be interested in. So for example, wetlands, a lot of wetlands are missing from that data. But to put this number in context, I did a little bit of math, and it turns out that the length of shoreline, that 1.5 million kilometers, if we circled the Earth, our riparian shoreline would go around the Earth 31 times. So that's a bit of a mind-boggling number, I would say, and it's an awful lot of riparian habitat for us to be assessing and managing. And so the second important question that we have when we want to manage ecosystems is, what condition is it in? And based on the massive amount of riparian habitat we have here in Alberta, this is a really challenging question for us to answer. Historically, the majority of the riparian assessments that have been conducted in Alberta have been field-based, so a lot of this work has been done by cows and fish. And while the field-based methods provide a really amazing amount of very detailed information about riparian areas, and they also, a huge benefit of this is engagement with landowners. If we were just going to rely entirely on field-based assessments, it would be really impractical and very expensive for us to be just putting boots on the ground to assess riparian areas. And so in the early 2000s, there was a new approach to assessing riparian areas called the aerial videography. And this method was developed by George Walker in conjunction with the Alberta Conservation Association. And this method captures video from low altitude flights. So in the case of George Walker, he used an ultralight airplane. And that ultralight collected imagery using a video. That the video then is interpreted by trained observers who fill out a condition scorecard that has a bunch of questions that are similar to the questions that you answer when you do a field-based assessment. More recently, aerial videography has sort of been adapted to be used with drones, so drones that are equipped with videos. And while this method, using the drones and also other types of airborne vehicles, provides really good information about the shoreline condition, the cost of this approach increases substantially when you're looking at larger areas. So for a single water body, it's a really good approach. But as you sort of try and scale up, the cost of this method really increases substantially, because if you're using a helicopter, for example, helicopter flight time is really expensive. And then in addition to those costs, you also have to pay to have someone sit and interpret all of the video that's collected, and that's all done manually. So it's really time consuming. And so the newest approach to assessing riparian areas here in Alberta is a satellite-based GIS assessment. And this is an approach that my firm developed starting in 2015 when we did some work with the North Saskatchewan Watershed Alliance. And given the vast amount of riparian habitat in Alberta, we saw a really critical and important need for us to have more tools in our riparian assessment toolbox. And in particular, to have a method that can be used to more rapidly assess the general condition of riparian habitat over really large areas. And so, you know, I want to note that all of these assessment methods have really distinct advantages, and some of them have drawbacks, and they're a little bit different in terms of the strengths and the weaknesses. But together, I think they provide us with a really useful array of different types of approaches to assessing riparian areas. And these approaches can be suited to, tailored to suit your purpose and your budget. So for the rest of my presentation, I'm really going to be focusing on the satellite-based method and describing for you how we use this method to assess riparian areas. And then I'm going to dive in and give you some of the results from the Pembina River Watershed assessment that we've done. So our satellite-based GIS method takes a bird's eye view of the shoreline of our water body. And the condition of the shoreline is assessed within what we call a riparian management area, or an RMA. And the length of each RMA is variable, and it's based on major changes in the proportion of natural cover that you find along the shoreline. So in this example, you can see that there are 3 different RMAs, and the length of each of those RMAs varies. But the width of our RMA is fixed, and we use a 50-meter buffer for the RMA width for our particular assessment. And within each RMA, we assess intactness, which is the sort of the measure of condition. And intactness is based on the proportion of natural versus human land cover types that are present within that RMA buffer. So the 50 meter buffer and the variable length. And a completely intact riparian area is a location that's entirely free from human disturbance. And a loss of intactness occurs as a result of habitat fragmentation or degradation that is caused by human activity. So in this example, RMA1 would receive a high intactness score, with intactness decreasing to very low within RMA number 3. One of the most common questions I get when I give this presentation, and you're probably thinking this already, is why 50 meter buffers? And so before I go on, I just want to address this question. As I mentioned earlier, the actual width of a riparian area is highly variable, and we know that the width of riparian areas changes based on a number of site-specific factors. And because of this, it's actually really challenging to accurately map the location of riparian habitats. And in most cases, it requires high-resolution terrain data to do it really accurately. And high-resolution terrain data and the processing that's required to analyze that data can be quite costly. And so while we would ideally be able to map riparian areas and assess intactness within those, within the extent of the actual riparian area, we feel that focusing this particular assessment on riparian management areas is more relevant for land use planners and decision makers. And that for most of the water bodies that we're interested in, 50 meters is actually a pretty relevant buffer distance. So just as an example of some of the sort of legislative and policy direction that we have in terms of setbacks on watercourses and protection of riparian areas, one good example is in municipalities. When lands are subdivided, municipalities can prescribe development setbacks on water bodies. And under the Municipal Government Act, there's a minimum setback of 6 meters required. And that's the minimum. So in some cases, we have municipalities here in Alberta where they have specific policies that address setbacks, or you may have a site where slope stability might be a really big issue. And so you can see setbacks that may be much larger. But I would say on average, it's pretty unusual to see, to consistently see a municipal setback that exceeds 30 meters. In the case of forestry setbacks, you typically see setbacks of between 20 and 60 meters for large rivers and streams. And in some cases, forestry setbacks require larger setbacks on large fish-bearing lakes of 100 meters. But for a lot of the riparian areas that we're interested in managing here in Alberta, which are located on private lands that aren't being subdivided, so are not sort of brought into the municipal planning process. And this includes a whole lot of riparian area that's based in agricultural landscapes. There are no legal requirements for setbacks to protect riparian habitats. So from a management perspective, we do feel that a 50 meter setback is really relevant and helpful when we're trying to focus our management efforts, because it does capture a lot of the landscape in which we're trying to engage with landowners who may be reluctant to give up a portion of their lands, especially if they're using it for cultivation, to protect riparian habitats. So before I go on to present the results of our work in the Pembina watershed, I just wanted to walk you through an example of the main steps that we use in our assessment. So the very first step that we use is that we have to take the provincial hydrography data, which is the foundation and the basis upon which we create the riparian assessment data. And we have to edit that data. So as most of you probably know, water boundaries are ever changing and water levels change annually based on